This talk, I apologize for being out of sequence, is going to review a proposed study that we've been doing, and it's really to look at remote sensing to inform viticulture practices. I'm very much not a viticulturalist, but the learning process has been fantastic, and I have to agree, I have learned so much just sitting here and listening to the talks. And this is fascinating. I've made some notes along the way. Um, but for those of you who don't know me, my name is Vanessa Escobar. I'm over at NASA Goddard in Maryland. I apologize for not being there in person. Um, the work that I'm going to present is going to specifically focus on microwaves, and I want to recognize my collaborators, Kyle McDonald and Aaron Dafford, up at College of New York. We have some test sites over in Long Island and in Yolo County that I'll be discussing during the talk. Now, for remote sensing, which we've heard plenty already, remote sensing and viticulture very well working hand in hand, and viticulture, grape chemistry, it's all very familiar with the different types of remote sensing, the spectral analysis that's sensitive to optical, near infrared, and thermal. I'm going to focus specifically on microwaves, mainly because we have a microwave mission that recently launched in January, and we've been working with a lot of airborne data as proxy for this particular mission. Now, the microwave mission that launched is called SMAP, Soil Moisture Active Passive, and we're going to use a UAV synthetic aperture radar as a test product for SMAP until it releases. If at any time, Virginie, this becomes difficult to hear, please let me know. I'm not able to see because my screen is actively being shared. So for this workshop, what I've been hearing is that one of the goals is to identify best practices, especially in irrigation and water savings, given the existing drought of California, and just how potentially dry or better movement for less irrigation is necessary. So using the soil moisture observations for this particular study and adapting them appropriately to what's going on right now within the viticulture research that I've been hearing about will hopefully help us scale these products from the UAV SAR airborne campaign and make them very usable and adaptable to the questions that have been asked repeatedly over the past few hours. So let's see. Now, benefits to microwave. I apologize for the wordy slide, but the benefits to microwave really is detecting soil moisture and vegetation water content. Now, microwaves can penetrate through clouds, so cloudy day observations are not an issue. We can extrapolate the root zone soil moisture from the surface data. The type of microwave we're using is 1.4 gigahertz, so it's an L band, and it can penetrate down to 5 centimeters of the surface soil moisture, and then we can extrapolate for root zone soil moisture, whether we're using ground observations or model data. Now, informing irrigation for broader areas is really the benefit of the remote sensing. We can capture a larger field of view and bigger fields in a shorter period of time. And that, in a sense, not only informs the practices for viticulture, but we're also hoping to inform the evapotranspirative models that are being used. And listening to Martine, I know they're using a particular ET model, but if you're using Weep metric, TOPS, or Alexi, the soil moisture is generally calculated or taken from a very specific region, very localized. So coupling a soil moisture observation over a broader area or field scale will hopefully inform these data sets and these models a little better. So not only provide you with broad perspective, but also giving you a nice profile of the soil moisture column. And we're doing some work with the USDA to improve that particular type of modeling effort. And then also, I heard Martine say this with regards to policy. And the drought monitor, ironically, is taking in the soil moisture data from the SMAP mission, and they're going to have an improved drought monitor forecast based on the microwave information they're taking in. But providing information that supports or responds to the water resource management that's going on in California, or even carbon management policy, if you're looking at the AB 32, it's all going to be incredibly useful. And looking at viticulture not only as a high value crop that can have very controlled water management, but also as a high value crop that can serve as a carbon sink and really have business as usual benefit the carbon greenhouse gas reduction is critical. So a lot of this information feeds directly into policy. Now, the motivation for this talk and for speaking with Thibaut and really hoping to get feedback from you in the audience is to see how can we best include soil moisture data sets into existing practices. And we want the process of feedback to come back into the product development of remote sensing. Like I said, this is very much a research effort. It's been in place a couple of years. We've been collecting data since 2009, but we've been scaling these products for viticulture the past year and a half, and mainly because the structure of the vines is so incredibly different than row crops, so you cannot use the traditional crop models. So ultimately, we would like to improve the timing and the efficiency of irrigation schedules using satellite data and coupling it with NDVI and with thermal, which are the data sets people are most familiar with, and then having the ET models also ingest this and to see what the improvement is, and hopefully those improvements. Thibaut has been fantastic, and we've kind of discussed some scenarios regarding how this could help really inform the growth. And that's what I'm really hoping to apply directly to the research. Now, again, this is really focusing on a proposal that we put together and working with some information from Gallo with Martin and with his team, trying to really understand what goes into a calibration field sort of data set and what is going to inform the irrigation schedules. And again, I'm going to focus on UAVSAR, and we really want to use the combination of the airborne, the satellite, and the ground data all together to give us a much better resolution of what the practices need to be if there's over irrigation, under irrigation, and how we can manage the water resources better. So I've mentioned UAVSAR quite a bit. You see off here to the right, that is the actual plane following the instrument. That is our UAVSAR. And then the image to the left is the SMAP satellite that recently launched. So this is the L-band remote sensing, and the parameters are very sensitive to soil moisture and vegetation when you're looking at microwave data. And the UAVSAR is synthetic aperture radar, but any information coming off of SMAP will be both radar and radiometer. So we're hoping that this information will potentially provide the data that you need, or at least a perspective that's necessary. This is the area of study that we've been focusing on now. We're looking at Yolo County, and the middle image is just the field that we've been working on. And off to the right, you'll see the swath for the UAVSAR transect in the southeast section of Yolo County. So this is the particular study site, and I'll start scaling down into that particular region. The time series that you see here is, these are two UAVSAR images, one for May and one for August. And you see three polarizations. So you have an HH polarization, HV, and VV. And that's just three color combinations of red, green, and blue that are giving you that purple hue. Now, as you look at May and then you look back to August, as you see that purple color tend to increase, that's very characteristic of an increase in moisture content, whether that's coming from the soil or that's coming from the vegetation water content. We need to get down into the resolution a little better, but you do see an increase. And you also see an increase in the green color if you just look at the image as a whole, and that is relative to the vegetation itself. So whether the structure of the canopy is increasing, but things are becoming more leafy. And so that's just kind of a nice view of what it looks like from the swath. Now, the spatial resolution of UAVSAR is 1 meter. We're rendering it at 5 meters just because it reduces the noise level for the analysis. These three small fields are what we're going to focus on, and they're almost half a kilometer in size. Um, these are the two captions, May and August, the close-up of 3 vineyards. It's very hard to tell from this image, which I'm just showing them so you have a scale for when we get to the next slide. From this image, if you look at May and August, you'll actually start to see a little bit of the color hue shift. Once again, you'll start to see the purples arise, and you can see that very well in fields 1 and 2 once we get into the backscatter, which I will end up staying here for a portion for the remainder of the talk so we can discuss the effects of microwave and how we're starting to see the response when it flies over a field at 2 different times of year. Now, this is for 2010. We flew over in May and in August, and the temperatures for May were around an average of 81 Fahrenheit for that month, and then for August, 91 Fahrenheit. But the precipitation, obviously, very, very, very small, 0.02 inches for May and 0.01 for August. So the drought continuing with vengeance. And right off the bat, you can see the difference between the May graphs and the August graphs. Just to explain really quickly, the hydrograph, the backscatter, essentially the response from the radar, is going to be sensitive to the moisture, which is you're going to see mainly in the HH and the VV, which I'm just going to refer to as the red and the blue peaks. And then a lot of the vegetation characteristics and the response from the vegetation is going to be seen in the green peaks. So if you look at field number 1, which is the farthest to the right, up on the chart on the top, you can see that immediately the width of the red peak is decreased when you go from May to August. Now, when you're decreasing the width of that peak, it just essentially means that you're becoming much more uniform within that field. So something within the field moisture, whether it's the soil or the vegetation, is becoming much more uniform or regular, whereas the backscatter is much highly scattered on the top. And the vegetation is actually the opposite. The peak is going from narrow to wide, so the vegetation itself is becoming less uniform, less regular. And this is where I was saying there needs to be continuity of the effort, because now what we have to do is go back and couple it with the ground data for these particular fields in Yolo County and validate our theories, thinking that if the soil moisture is becoming more uniform, maybe there's a more even distribution of irrigation, because you do see the peaks increase, but you also see the vegetation become less regular. So does this necessarily mean that it's becoming more leafy? And that again is something that we want to validate with ground data. For field number 2, there is a drastic change, and I think this is the most interesting of the 3 charts. You see the red peak and the blue peak essentially swap places, and that is a drastic change in increasing of moisture, and whether it's soil moisture or vegetation water content, there is a very drastic change. It's a shift off to the right and a narrowing of the peak, so it's becoming much more regular, which leads one to believe that there may have been a major irrigation event at that time. Clearly it wasn't precipitation, but moisture has increased in that particular field. Vegetation itself has become much more narrow, so the question again, the structure of the vines have changed significantly from May into August, and again that is up to us to now go out, see the field data and validate it. And then again, you see some similar actions on field number 3, where you have your blue and your red peak overlapping with each other, and then you see a nice drastic shift of the red peak to the right, which again is characteristic of any kind of moisture, potentially soil moisture, and a shift off to the right. So it's not a very uniform distribution of moisture, as you see the peak shorten and widen a bit, but you do see an increase. And then again, the vegetation remains pretty much the same. So what we want to do is take these UAV SAR data, which seem to be scaled fairly well to the field and give us enough information, and couple them with NDVI and with the thermal products that are being used right now. One thing that we were very happy about is that we received signals that were able to tell us, clear shifts to the right or the left, or clear increases in moisture or changes in the vegetation content, mainly because of the metal stakes. We were unsure of the feedback we were going to get, or the interference we were going to get from the metal stakes in the rows. So that has proven not to be an issue right now, and so we have a large amount of data from 2009 to present over the entire state of California that we would like to process and look at vineyards from different locations and start to make some correlations and start to overlap it with the NDVI, and start having the actual observations for soil moisture combined with the calculated root zones and the extrapolated root zone soil moistures that you're getting from your models as well as from your probes. And this was just, again, emphasizing how the width, the shift to the right, and then again a shift to the right and also an increase in the width, how that's all characteristic of changes in moisture between May and August. And the conversation I had with Thibaut, it seems as though this does make sense in terms of the irrigation, especially if you're going to get into the management of your leaf growth. So that's where I would really be very interested to hear from you, as far as does the data reflect the practice, and how can we better scale the data to give you more information. And I would much rather go into conversation and discussion and hear from you and answer any questions that you may have, and hopefully provide you with a little more detail.
Vanessa, what is the frequency? What is the frequency of those flights? Like, how often do you provide such images, and how easily are they for anyone here?
The frequency of the flights, because it's a research mission right now, we schedule the flights depending on requests and paths. And so this could very easily turn into a dedicated mission type instrument where we have regular paths depending on the growing season and when it's necessary. But at this moment, it hasn't been targeted for viticulture, Thibaut. So we fly it with respect to combined requests altogether. And what I've been trying to do is take advantage of the times the UAV SAR does go out and make sure we fly over vineyards. So.
Okay.
So
thank you very much, Vanessa. Yeah, we will relay any questions to you.
Thank you so much.
Okay, thank you so much.
Bye.